I have to laugh a little bit because I just recorded this intro and forgot to unmute my microphone, so it would have been a pantomime. Anyway, hello biostatisticians. This is another set of videos, 3 videos actually, from Dr. Mary Mays, pulled from the archives for your viewing entertainment. Dr. Mays goes over how to use an applet that has been linked in our course that allows you to convert from z-scores to p-values, and it helps you to kind of develop a intuition around what different p-values mean and what it is that the z-scores are telling you. Also, you can use it to think about percentile ranks and things like that. It's not going to be required that you use, but it is pretty cool to look at, pretty useful to start developing your thinking. So I encourage you to watch the video. It's only about 15 minutes. Play with the applet if you have time. And remember that you can refer back to these things later if you need them at a later time as well. So, enjoy the video.
Hi everyone, I'm going to show you an applet today on the internet that I think will help you understand z-scores and what they can do for you. So we're here at the Weiss website, and if you look to the left you'll see a menu table of contents, and as you look down you'll see that my little hand thingy is poised over the P to Z converter applet. When I click on there, it takes me out here. Now, I've been here a couple times today practicing, and so this loaded almost instantly for me. It will take up to a minute to download to your computer the very first time. And it's really not downloading to your computer, it's just downloading out to the cloud, so to speak, so that you can access it from your computer. So it doesn't add or subtract anything from your computer. And you can use just this little part of the applet to convert or to look up the probability of a particular z-score, but I didn't find that particularly helpful. What I found helpful was this graphic. So when you get here, click on the graphic button, and you will see that it starts out with a standard normal distribution where the mean is 0, the standard deviation is 1, and it has found for you the 0.5 point on the distribution. This is very typical when you're doing a normal distribution test that we set alpha at 0.05. And we're going to talk about that a whole lot more later, but that's just the way, that's the default position. What we want to do is play around a little bit. So we're trying to learn what the percentages are under the curve, what the area under the curve is. So let's drag right straight here to the mean and line it up perfectly with 0. And now you'll see that our raw score is 0, our z-score is 0, and that we're at exactly the 50% mark. There's 50% of the distribution above the mean and 50% of the distribution below the mean, and that's what it tells us right here. We're at a probability of 50%. And that's really great. We can play around with that. We can drag it to exactly 1 standard deviation above the mean. Takes a little bit to line it up. So you see that the raw score is 1, the z-score is 1, and it tells us that 84% of the people in this population score below, that's the blue area, and 16% score above, that's the red area, and you notice that that corresponds with the diagram in your book. So if you want to look up what a standard deviation is in terms of percentages, the area under the curve to the left of that z-score or to the right, this is a great little app for doing that. But let's do something else. And this is tricky, so you need to listen to this carefully. You can only change 1 box at a time. So even though I want to change 3 or 4 boxes in order to get to my answer, I can only change them 1 at a time. So the first thing I'm going to do is to make the mean 100. So I type in 100 and hit the enter key. And of course it messes up the whole picture, but we're not going to worry about that right now. I want the standard deviation to be 10. So I go to the standard deviation box, type in 10, hit the return key. Alright, notice that it has adjusted these scores. The mean is at 100 and the first standard deviation is at 110, which is 100 plus 10. But now I'm more interested in finding out a z-score of 100. I'm sorry, a z-score of 0. Now think about that for a minute. What would a z-score of 0 get me before I hit the return key? A z-score of 0 should be right at the mean. It should be at the 50% point, because the mean is always a standard deviation of 0, or a z-score of 0. So I'm going to hit the return key, watch what happens. And you see that I'm now right at the mean, because the mean is 100, and the mean, of course, the raw score, you notice how it's changed the raw score, changed the 50% here, and changed the 50% here. Let's look up an odd z-score. You know, I've been doing easy z-scores to make the math easy. Let's change this z-score, and let's make it a negative 2.2. Now, before I hit the return key, where do you think this is going to go? Picking up where we left off. We had set the mean at 100, we had set the standard deviation at 10, and we had just changed the z-score to 2.2. But nothing has moved yet because we haven't hit the return key. I want you to think in your mind, a negative 2.2 z-score. Well, if it's negative, obviously the line's going to move in a negative direction. If it's 2 standard deviations below the mean, then 90 is 1 standard deviation, 80 is 2 standard deviations, so it's going to be slightly less than 80. And how much area under the curve, what percentage of people are going to score less than 80? In this case, slightly less than 80. It should be around 2% or so. So I'm going to hit the return key now and watch what happens. It moved to a little bit more or less than 80 than I thought it would. The score is 78. And we see that 99% of the people score above that score. That's also reflected here. And 0.01% score below that score. So, pretty interesting. We can do this any way we want to. We can drag it here to a probability of exactly 90% is what I'm trying to get to. We'll make it 90.1. Alright, so 0.90. This is the point where 90% of people score above that score. And what score is that? Well, it's a raw score of 87.143. It's a z-score of negative 1.29. We'll round it. Alright, so to the left of that then, if 90% score above it, then 10% score below it. In this case, 0.099. We'll round that to 10%. So please come out and play with this applet and use it to begin to understand this concept of area under the curve, and how, if you know the mean and the standard deviation, you can always find the score in that distribution, and it will tell you something about the importance of that value. It will tell you how many people score below it and how many people score above it in a normal distribution. Okay, this is the third video tutorial on this P to Z converter applet, and this is the advanced version of our program. You'll notice that we've set the converter to give us the information about 2 tails, what's in each tail, the red, and what's in the middle, the blue. And you'll notice we're dealing with a standard normal distribution with a mean of 0 and a standard deviation of 1. And we've put the boundary markers at 2 standard deviations, positive 2 standard deviations here and negative 2 standard deviations here. And if you think about what you've learned in the lesson, you know that 95% of all scores score inside this blue area. And that is what it tells us here. The probability of scores in the middle is 0.95, and the probability of scoring in either tail is 0.05. I'm sorry. Yes, in either tail, that's correct, it's 0.05. So in the upper tail, it's 0.025, and in the lower tail it's 0.025. Add those together and you get a probability of 0.05 of being in either tail. Alright, play away and experiment with moving the marker up and down. If we look at how many scores are in between +1 and -1 standard deviations, we see that it is 68%, just like the picture in your book. Alright, great. Have a good time playing with this. Remember, you can change the mean and standard deviation to match any score distribution you want.